Pure Mathematics A-Level Paper 2. The roots of the quadratic equation x squared minus x plus 2 equals 0 are alpha and beta. Prove that a 1 over 1 plus alpha squared plus 1 over 1 plus beta squared is equals to negative half. B 1 over 1 plus alpha squared times 1 over 1 plus beta squared equals half. Hence, form a quadratic equation whose roots are 1 over 1 plus alpha squared and 1 over 1 plus beta squared. June 2014. If we compare this equation to the general quadratic equation ax squared plus bx plus c equals to 0, we'll see that a is equals to 1. The coefficient of x squared here is 1. B is equals to minus 1. The coefficient of x here is minus 1. C is equals to 2. We also have to know that if a quadratic equation has roots alpha and beta, then the sum of roots alpha plus beta is given by the formula negative b all over a, and the product of roots alpha times beta is given by the formula c over a. B is negative 1, a is 1. I'll put negative 1 in the place of b and I put 1 in the place of a. This would give me negative into minus 1 all over 1. Minus times minus is plus, which is equals to 1 over 1. 1 over 1 is 1. It means alpha plus beta is equals to 1. C is 2, a is 1. I'll put 2 in the place of c and 1 in the place of a. That is 2 over 1. 2 divided by 1 is the same like 2. That means alpha times beta is equals to 2. Now we know that alpha plus beta is equals to 1 and alpha times beta is equals to 2. We are required to show this. To show that the left hand side of this equation is equals to the right hand side, we need to start from the left hand side, and then we show that the left hand side is equals to the right hand side of the equation. That is 1 over 1 plus alpha squared plus 1 over 1 plus beta squared. We take the LCM, which is the product of these denominators. 1 plus alpha squared times 1 plus beta squared. 1 plus alpha squared goes here, 1 plus beta squared times. That's 1 plus alpha squared cancels 1 plus alpha squared here, and we are left with 1 plus beta squared. 1 plus beta squared times 1 is 1 plus beta squared. 1 plus beta squared goes here, 1 plus alpha squared times. That is 1 plus beta squared cancels 1 plus beta squared, and we are left with 1 plus alpha squared times 1 plus 1 plus alpha squared. This is equals to 1 plus 1, which is 2. 2 plus alpha squared plus beta squared all over 1 plus alpha squared times 1 plus beta squared. You need to multiply the denominator out. So we have 2 plus alpha squared plus beta squared over 1 times all this bracket plus alpha squared times all this bracket. 1 times this bracket will give me 1 times 1, which is 1. 1 times beta squared, which is beta squared, as plus beta squared. Alpha squared times 1 plus alpha squared. Alpha squared times beta squared plus alpha squared beta squared. Now I need to arrange this numerator here in terms of alpha plus beta and alpha beta, and I need to arrange the denominator in terms of alpha plus beta and alpha beta. That is 2 plus alpha squared plus beta squared all over 1 plus beta squared plus alpha squared plus alpha squared beta squared is equals to 2 plus alpha plus beta all squared minus 2 alpha beta. You know that alpha squared plus beta squared can be expressed as alpha plus beta squared minus 2 alpha beta. This is a formula which needs to be recalled all the time when dealing with problems like this. All over alpha squared plus beta squared plus alpha beta all squared plus 1. You know from indices, a times b to the n is the same like a to the n, b to the n. That's why alpha squared beta squared is the same like alpha beta all squared, where n here is 2, which is equals to 2 plus alpha plus beta all squared minus 2 alpha beta all over alpha plus beta all squared minus 2 alpha beta plus alpha beta all squared plus 1. Alpha squared plus beta squared is the same like this formula. That is why I've replaced alpha squared plus beta squared with this, which equals to 2 plus 1 square, since alpha plus beta is equals to 1, minus 2 into 2, since alpha beta is equals to 2, all over 1 square minus 2 into 2 plus 2 squared plus 1, which is equals to 1 square is 1, 2 plus 1 is 3, that is 3 minus 2 times 2, 2 times 2 is 4, minus 4 all over 1 square is 1, 1 minus 4, 2 times 2 is 4, 1 minus 4 minus 3, 2 squared is 4 plus 1 5 minus 3 plus 5, which is equals to 3 minus 4 is minus 1, minus 3 plus 5 is 2, that's minus 1 over 2 as required, and the proof ends. We are also required to prove that 1 over 1 plus alpha squared times 1 over 1 plus beta squared equals half. This is the left hand side of the equal sign. This is the right hand side. To prove this, we need to start from the left hand side so as to obtain the right hand side. That is left hand side, right hand side. Let's start from the left hand side. 1 over 1 plus alpha squared times 1 over 1 plus beta squared is equals to 1 times 1 all over 1 plus alpha squared times 1 plus beta squared is equals to 1 times 1 is 1. So I need to expand this denominator. 1 times all this bracket plus alpha squared times all this bracket. 1 times 1 is 1. 1 times beta squared plus beta squared. Alpha squared times 1 plus alpha squared. Alpha squared times beta squared plus alpha squared beta squared. This denominator can still be arranged. That is 1 equals to 1 over 1 plus alpha squared plus beta squared plus alpha beta all squared. Since alpha squared plus beta squared is the same like alpha beta all squared, which is equals to 1 over 1 plus alpha plus beta all squared minus 2 alpha beta plus alpha beta all squared. We know alpha squared plus beta squared is the same like alpha plus beta minus 2 alpha beta. I repeat, it's a formula which needs to be recalled all the time. So it is advisable to memorize this formula. Now in the place of alpha plus beta, I'll put 1. In the place of alpha beta, I'll put 2, which is equals to 1 all over 1 plus 1 squared minus 2 into 2, since alpha beta is 2, plus 2 squared, which is the same like 1 over 1 square is 1. 1 plus 1 is 2. 2 times 2 is 4. 2 minus 2 is 0, which is the same like 1 over 1 plus 1, which is 2, since 1 square is 1. That is 2 minus 4 plus 4, since 2 squared is 4. Minus 4 plus 4 is 0, which will give us 1 over 2. Quite a Erasmus demonstratum. And the proof ends. We are supposed to form a new quadratic equation with roots 1 over 1 plus alpha squared and 1 over 1 plus beta squared. New quadratic equation can be obtained from the formula x squared minus sx plus p equals to 0. S means sum of root. P means product of roots. Sum of roots, that is 1 over 1 plus alpha squared plus 1 over 1 plus beta squared. We know from the A part of the question, this expression was equals to negative half. Product of roots 1 over 1 plus alpha squared times 1 over 1 plus beta squared. From the B part of the question, we know this expression was equals to half. Using this formula, I'm going to replace in the place of S sum of roots, which is minus half, in the place of P product of roots, which is half. That is x squared minus into minus half x plus half is equals to 0. Minus times minus is plus. That is x squared plus half x plus half is equals to 0. To simplify this equation, I need to remove these 2 from the denominator. To do this, I need to multiply the left hand side of the equation by 2 and the right hand side of the equation by 2. You know 2 times 0 is 0. That is 2 times x squared plus 1 over 2x plus half is equals to 0. 2 times x squared is 2x squared plus 2 times half x plus 2 times half is equals to 0. You know to multiply the left hand side by 2, I need to multiply each term by 2, which gave me this one. 2 one time, 2 one time, 2 here, cancel 2 here. I'll be left with 1x and then 1. That is 2x squared plus 1x, which is x plus 1 is equals to 0. This gives the equation we are required to form.